Today's a new project, but before that I want to discuss about my work holding options for that small lathe I have over there. So this is the 3-jaw chuck which came with the lathe, and I modified it to make it a true chuck. Has a reversible, it has separate jaws, so for external you need to remove this and mount this. Then I have the 4-jaw chuck which came with the machine. You can take this jaw independently out and flip them around so you can clamp on the external diameter. And this plate also came with the lathe. This I bought at a later time. I made this also a true chuck with the 4 screws here, and I'm using this most of the time because it has a bigger clamping capacity than these small ones. And lately you have seen me using this mounted directly in the spindle. So, and occasionally I use this, which has the same ER40 collet, but gives me an advantage that there is a space here big enough so I can have the stock going through the spindle, while here the hole is too small to do something like that. So my challenge with this one is every time so it's mounted with a drawbar, so there is a bar, like threaded rod, which gets clamped on the other end of the spindle. And then every time I need to take this out, I need to hit that bar to get it off the taper. And I don't like that because all that hitting goes into the bearings. And some while back, I bought a 5C collet. Actually, I bought 2 of them because I forgot where I put the first one when I moved to this house, and I thought I lost it, so I bought another one. So I have 5C collets for this, both metric and imperial. This is how they look like. There's a taper here. But I'm thinking now, if I'm mounting this, I have the advantage of using either the 5C collets, metric or imperial, or put this adapter, it is 5C on this side and ER collet on the other side. So without too much hassle, I can jump from one world to another. Now, from the geometry of this 5C collet, they will clamp very well at the end here, right? When this taper is compressed, it will hinge here, it will clamp here, right? For the ER collets, I think is besides clamping a larger range, 1 millimeter, this is not clamping a larger range. So your stock needs to be, very close to 932. You cannot have in between. ER collets, they allow you to have a larger range because there is 1 millimeter clamping capability in each one of them, so basically you can have all the range. Now if you look at the geometry of this, it has a slit here and a slit here, so it compresses at both ends when it's clamping on the round stock. And I think because this is thicker here at the joint point, this will much easily compress at the back than at the front. So probably these are tightening better at the back than at the front because of that. On the other side, I'm not sure 100% because this is taper, so it might be uniformly clamping them. But anyway, the clamping length, it's much bigger than you would see in a 5C collet, which is only at the tip there. You can see in the hole, it's just at the tip, so it's this portion here. So if you have something long, it can wobble, being clamped only in the middle. So anyway, one of these 2, I don't remember which one, they seem to be the same dimension-wise, came with a back plate. This is the back plate. And it's not fitting my lathe. I mean, thread is okay, but it's 45 millimeter inside. And my lathe accepts 46. Also, this register feature here is 15 millimeters long, and on this new one it's like 10 or 11. So I'll have to machine this to match my spindle. Now the dilemma I have, I measured the spindle here with a micrometer, and I was thinking, okay, I'm gonna match exactly my spindle, but I have two spare spindles for my lathe, and I measured them, so they're within 1,000 difference from one another. So I was targeting this to be a very close fit, like 5 microns between this and my spindle, but with 1,000 with the other two, if I need to change the spindle, the one I have, if it gets damaged or whatever, then they will not fit here. So I'm not sure what to do now. I don't want to be loose. I'm thinking maybe make this to match my existing spindle on the lathe, and then when I change it with a spare, then I'll have to make it a little larger. The one I have on the lathe is the smallest in the diameter, so maybe we go with that plan. So that's for 5C collet. Also have this chuck, which is a 6 jaw, can clamp large diameter. That's approximately the maximum. The advantage of this is you can clamp like tubes, thin wall, and it will not deform like a 3 jaw chuck, which applies pressure in 3 points. This applies in 6. I don't know how good this is, and even if I can grind it, the jaws, they will be accurate at that diameter. As soon as you move the jaws in and out, you lose that precision. So I'll have to make this as well a true chuck with that extra ring in between. Now I have a spare backplate here. I was planning to use for this as well, but I'm thinking to keep it for maybe some other future parts, and I would rather buy from McMaster & Carr a 6-inch diameter, maybe 1.5 inch long, maybe 2-inch long cast iron, and make that back plate from scratch instead of using this. So enough with the talking. I'm gonna mount this in the spindle and machine this to match. See you there. I already machined this, but before doing that, I found a better way to measure my 3 spindles. So I use this device, and I have 2 gauge blocks, the 40 and the 6 millimeters. That's 46 millimeters, and I measured all 3 spindles. The spindle I have on the machine, I measure with a bore gauge with a 1 micron meter indicator on this device, right? I zeroed it, and then I took a caliper and measured the spindles, and then used this between the caliper anvil to see the deviation. So the spindle on the lathe is 3 microns under 46 millimeter, and the second spindle is 4 microns, and the third spindle is 8 microns. And I went for 3 microns over. We can check this out. You can see goes to 3 microns there, close, 2 microns, 3 microns, and it fits perfectly on the spindle, and also fits all 3 spindles. So now I'm oh, by the way, the chuck which came with the lathe, it's like 35 microns over, so that's what, 1.5 thousandths, way loose than what I have created. So now I have to I have to machine this backplate. I decided to use backplate. Initially I wanted to buy a piece of cast iron from McMaster & Carr, but it's like $75 without shipping. And this I bought from Shars for $76, and already has the threaded hole. So, I'm gonna go with this and machine this next the same way, 3 microns, and then mount the 5C collet and see how accurate it is. I'm ready to machine this backplate, this boss here, and face it here to mount the 5C collet. The way I'm gonna do it, I'm gonna back this insert up to the face and mount this top here. And then this boss is 97.5 millimeter. I need to bring that to 95. And when I'm approaching the 95, I'll just try to mount this to be as close as possible. And as soon as I reach that dimension, then I'm gonna feed from here the insert into that corner, and then feed out, so the two surfaces, you know, they are perpendicular to one another. Oh, I overshot. God damn it. Guess I'm gonna make this a true chuck after all. With the rings, with an extra ring here for adjustment. But then I need to buy a tube. Mount this here with two screws, and then another ring here, so gonna be a ring in between, so I can adjust this. Well, I'm gonna try to put the screws and see if I can adjust it this way for now. And let me face out now. Okay. Here are all the parts we need to machine. So we're gonna make this through chuck. I have explained how that works. Basically, you have this ring gets registered here, mounted with the 3 screws from the front. And then on the back plate, which gets mounted on the lathe, you have this ring mounted here again with the registry here. And it has a reduced diameter, so it fits in here. And basically you have this adjustment in this plane, and to make that adjustment you have 4 set screws in the ring which are pushing against the inner ring. And for the push location I bought some high-speed steel 10 millimeter diameter to press it on the location where the screws are pushing. So we're gonna do that for the 5C collet chuck, and we're gonna do the same. This is another back plate. We're gonna do exactly the same for the 6 jaw chuck here. Make this a true chuck. Okay, 6004. A bit over, but we can compensate when we make the register on the back plate to be exactly where we want it to be. I need to chamfer. Never tried this chamfering tool. Will it interfere or not? Yeah, maybe not. Let me try it out. Let's try this. Let's see how good it is. Let's see. I need to center this ring. It's 5 inches and my 5C chuck is 5 inches as well. Since I have to take some to clean this surface, I want to take the minimum possible. Now I'm gonna be under 5 inches, but that's okay. So I have 10,000 out of round. I need to adjust this through chuck, loosen the screws on the back, just snug tight. And now, let's see, that's 0, that's 10. So I need to be in the middle. Okay, so now we are oscillating between -5 and +5. So whichever screw I'm adjusting out of the 4, I need to see 0 on the dial. When I see 0 on the dial, I'm aligned. Okay, we have 0 here. Let's go this way. We have -4, -5. Too much. Okay, so I'm oscillating 1-2000 because the surface is rough, but that's okay. We are on 0. Tighten these screws on the back. Okay. Yeah, it's good enough for how rough it is. So let's face it. 95.19. Okay, so I have to wait to cool it down. Well, I machined it off camera and I'm using my Mitutoyo dial caliper, because the other one, it's a cheap one, no name, and I don't trust them. But this is showing me 9501 here, so that's what, 10 microns there. And it looks like, without chamfering here, this looks like it's gonna fit just right. I'm afraid to, because I don't know how I'm taking it out, but it fits. So I need to chamfer now. So let's do chamfering here. Both places. Chamfer here. Oh yes, no play, it's perfect, perfectamente. Now I need to turn this ring around and face it, because this, it's get clamped on the back plate, mounted on the spindle. So not sure how parallel these are when I mount it this way. So I don't know this face how parallel with this face. Make this flat plane might be off 1000 or less with this surface, but then gets mounted on the spindle, and I'm gonna take a light pass here, just come in the corner and take a light pass, so then the two surfaces are parallel and align with the spindle. I don't need to mess with the register, because see, the challenges I have now is this ring is touching here, not where the surface is ground. So I'm not gonna have, not even, somewhat close parallel. Maybe I'll check it on the interior diameter and then center it here measure on this side, make sure it's in the plane. I'll have to figure out something because I did a mistake. Should have made this first mounted this way and then machine this, but I forgot. So I now have to figure out a way. Lucky me, I had machined these jaws so I could clamp 8 inches, and they were turned on the lathe, so these surfaces are in the same plane and they are numbered, so they went back into the position I machined them. So now I can mount this here because I have enough surface to stay flat on that lip. So we can do this now. Switch to this. See what we this is it. Now we need to put 4 screws or something, 3, 4, thinking 4, and then I'm gonna machine this surface and this surface to size. Question is, can I remove this chuck now, this back plate? Oh, I can. Awesome. Awesome. It's hot. Okay. So, see, that's why I need to machine this exterior after it's mounted, because there is no clearance between the 2 rings. I need to leave, I don't know, half a millimeter, anyway, it's like, so I leave it room for that centering. So I'm gonna machine this I cannot because I have this lip here, but that's how they're coming together pretty much. When that ring goes over the other ring, like so, this gets machined, then you have 4 screws, and you adjust this in relation with this. Awesome. We are close. Now I need to do milling. I'm gonna use a transfer punch, the closest I can find which fits this diameter. It's 9mm. I try with both imperial and metric. Seems 9mm fits the best, so I'm gonna transfer this and then thread that hole, clamp it, and then make the other two the same. Okay, so we clamped these 3 screws. Now we need to make 3 holes on the back here. Shift it 60 degrees from the other ones. This is where I have the hole, so shift 60 degrees. I have another 3 which get mounted on on this back plate. So we are doing this, right? We drill 3 holes for metric 8 with the head under the surface, and we center this ring as much as we can based on the inner diameter in relationship with this. Drill 3 holes in this plate, center punch once we have the alignment, and then drill and tap 3 holes here. And then we can enlarge this hole from 8mm to 9, because we need that clearance so we can make the adjustment I mentioned. And then after that, we can detach the ring from the chuck, attach it from the back plate, put this back on the lathe, center on the inner ring diameter, the internal diameter of the ring, and then do a facing here one more time, so they'll be parallel with this one. And then we can take this ring and mount it on this plate and machine it down. That's the order. I'm about to drill these 4 holes at 45 degrees, and I thought I'll use this, see how good it is, because the collet I have is not that good. So if I hold on to this, that's the best I could. But you see how this whole body is wobbling. I tried 90 degrees and all around. It moves about the same, but I'm not sure, so I'm gonna try with this. I'm gonna try with this with a dial indicator. I'll see. I mean, in the same position, I zeroed the arrow. See if I get the same. Okay, so I put this 1/10,000 dial indicator, dial test, and it's up. I recentered using this one, right? So I'm not perfect. I'm not down to 1/10,000, but moving around, maybe I'm 1,000, which is okay for this application. So I recentered with this, and look at the numbers here. So this is millimeters, 0.2 and 0.015. That's how bad this guy is. I mean, the body or the collet or the combination of everything. So can't use this piece of crap. So I'm gonna use this to drill the holes. So now I'm centered. I can zero the arrow here. Maybe saving one more location so I'm not losing it. Maybe 2. Let's save it here as well. So then I'll have to do now the PCD 4 holes at 70 millimeter diameter, 45 degrees, where these lines are. I'm thinking to use this. They're stainless steel, I don't care about that, but the problem is the regular ones, the head is too big. So it's like 12.4. And this is 11.4. So well, 12 millimeter, which I can use to make that sit in the ring without having to. If I use this with a bigger head, I'll have to put them on the lathe and reduce the head. So don't want to do that. See, it's too big, but this seems to be okay. It will work with this. Okay, so here it goes. I need to align these holes somehow. I think I'm going, I don't know, it's like that. Symmetrical here somehow. Yeah, I think that's good. I'm gonna center punch one of them and then drill tap, put a screw to keep it in position, and then do the other ones. Okay, that's good enough for a center. Probably I'll have to clamp this here. Have to remove this with the drill, the chuck, and then do this. Oh shit, motherfucker. God damn it. Broke the goddamn tap here. I'm not sure I'm gonna get this out. Well, I have to see that. I'm trying to cut that up with an end mill, but with what, it's a 4mm or 5, but the collet is not that good. It's wobbling, so I don't know how it will go. Nothing happens. Nothing happens. Maybe only dull. Anyway, not gonna do anything. Let's try one more time. Not gonna budge. Yeah, still nothing. Well, bad luck. Now I have to turn this with the carbide. Now I need to drill another hole. God damn it. I don't like that. I don't like that. Where were you? Here. move around. Start all over. Maybe better luck with this one. God damn it. Take two. This material is so gummy. Better back it out than having the same surprise. Uh-oh, that's it. End of the hole. Okay. Okay, so now we can do this with all of them. Need to blow air here, but need to start the compressor. But I have these three. I'm gonna make them off camera. I have all 4 screw mounted. When I take them off, face this to remove that tap, the head of the tap. This is 28 now, it needs to go to 24. So I'm gonna, on the lathe, after I mount, clamp it in the screw, clean this surface, and then cut to length 22 millimeters, and this part will be done. So this is done, and have that play around it. Probably it's 2 millimeter, 1.5. Now I need to machine the holes which mounts this from the back plate to the ring, and then the 4 screws, and then we're done with this. We need to make this thinner with 2.66 millimeters, so I'm gonna reach this point so where my DRO is 0, and I have the stop set there as well. So starting here, it should be 266 or about. Maybe I should center this. Okay, I need to chamfer here. Yeah, I'll center it off camera. I busted the insert somehow. Not sure how. Need to change that. Change the insert with one with a larger radius. Let's see how this goes. Okay, now we need to drill holes. I was looking at my options here, how to drill the holes in this. Right, so I have this hole which goes in the ring, and hole in the inner ring at 90 degrees, so here, 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 and here. And then I need to drill these holes at 120 degrees. So this, actually that's the location. So it's 60 degrees from here. These are 120, so I have 60 and then 60. So it doesn't matter how you look at it, I will always have 15 degrees from here to here. And so I will have here, because it's 90 minus 60 divided by 2 is 15 degrees. No matter where you look, I will always have that 15 degrees. So ideally, I want to find something to drill the holes on the face, right? Drill them through and then tap them. And then rotate the whole assembly so I can maintain the angles. And then drill these holes at 90 degree. So looking at my options here, how do I do that? It seems the most reasonable option would be to go with this dividing head, because I can get that angle accurately through this plate, and I can find a plate which gives me 1 degree, right? So 360. Problem is, this came, unfinished. It's not machined. So I'll have to machine this pretty accurately so it stays flat and perpendicular with the axis. And I don't know how to do that yet. Another option I have is to use my 8-inch 200mm rotary table. I have this big 10-inch chuck. I have hardware to mount this on the table and center it. The problem is, and that will be good because I can machine vertically the holes and then flip it 90 degrees, have the angles maintained, and do the 90 degrees. The problem, this is so freaking heavy, to turn that, hold that, turn it 90 degrees, realigning on the table, and do the other holes. I don't know. It's the third option I have. I have this spin dexter or whatever it's called. It's in 1 degrees, right? So you can get 1 degree, 360 position, which is fine for what I need. But trying to clamp this here, it's gonna be hard to find 90 degrees here because it will interfere with the jaws. I mean, it doesn't matter where I'm trying to sit it. I will have that problem. So let's see what options we have here. So these are my 90 degrees, right? So it doesn't matter if I stay here. See, I am limited. These holes are 8 millimeters in diameter. Definitely I'm gonna hit that jaw, right? There's no way to do that. I mean, these are fine. I can put a spacer and drill this through, right, with a spacer here. But then I have this challenge, and then how the heck am I gonna put this vertically? I mean, I can take it off from here, but then I'm losing the indexing. So, not sure. It seems like the only option I have is to go with this and struggle to lift, turn that 90 degrees on the milling machine table. Would love to have this because that will be, there's some space considerations here for tapping those holes with metric 8 because I cannot use this anymore. I have to use a tap wrench, but that's okay because I have enough space here, right, to do that. And the nice thing about this is, once I'm done in this direction, just gonna turn this 90 degrees, align it with the dial indicator. I have all the angles here I need, and I can drill the 90 degrees. So from these two options, the big rotary table and this, maybe I take a second project and make this so I can use it in the future. I bought this like 6 years ago, never used it ever. So why not? So now I will be able to use it if I machine this properly. Yeah, probably I'll try that. Well, the plan with this would not work because even I machine this, I don't know how accurate I can be, and it will not be concentric, because I cannot machine that accurate. That's why all my chuck are true chucks. Like this one is a true chuck. The one I have on the lathe is a true chuck here. This other chuck is a true chuck. And even the one I'm working on now, right? All this 5C Collet, the 6-jaw chuck, the chuck for the CNC lathe. So I'll have to make this a true jaw chuck, and I don't have the material for that. But it would work. I have enough clearance here. I need to drill 8.5 millimeters for a metric 10 by 1.5. So this is 8.5 millimeter center punch. So it looks like I have clearance here because the jaws are on the outside. So one here and one here. I'm at the limit, but there is space. So what I think I'm gonna do is mount this on the table with clamps and align the spindle in the ring here, and then put 2 screws here with a straight non-threaded part going out from the holes, and then put a something like this on the cylindrical part and align this with the axis, and then drill the 3 holes. Drill these 3 holes. This should be 6.7 millimeter for metric 8 by 125. So I can do them 6 millimeter, and then I can put dowel pins into this. Right, I just needed one of them. Put dowel pin into one of them, then mount this ring here, align it on 0 on the pin here, and then use a dial indicator and the dowel pin to 0 vertically. And then I can move 15 degrees and then 90, 90, 90, right? Because that's what I have. I have from here to here 15 degrees, and then each one of these red line is 90 degrees. So that will be much easier. I don't have to machine this because I don't have the material. I don't have to use this jaw even with this if I use it, because I was thinking of that option as well. I put this somewhere. So I can put the ring here, right? I can put the ring like this, and it's on spacers, so it's not touching the jaw, right? I'm gonna sit like this on the spacers, and I cannot find an arrangement like, you know, these are 90 degrees, so my 90 degrees are in between, and this would be fine to drill them. But then I have to go with that rotary table, and that's not the only challenge. The challenge is the distance from here to here. It's too big. I don't have a center drill this long. I do have drills which are 6 inches long and 12 inches long to actually drill, but I don't have a center drill to get from here to here, right? Because the chuck will interfere, because not much here, right? Don't have much space here for the chuck, or maybe I do have. Let's see. How much do we have here? Because I need to be like 20 millimeters from this edge this way. So 20 millimeters. It's about, I don't know, what do you say there? 30 millimeters. Okay, so the chuck is what? The chuck is, oh, you know what? It might fit because the chuck is under 60 millimeter. So it might fit here. Right, that's 30. I have 20 there. Actually, now I have to be 10 from this. This is 20 millimeter. I have to be 10 from here to here. So yeah, not gonna fit. Not going to fit. I'm at the limit. Unless I'm putting bigger spacers and I clamp on the edge there. Yeah, I mean, if I put taller spacers, that'll work. I'll just struggle to tilt this assembly together. So maybe I'll do that. We'll see which one is easier. Found an arrangement which will work. So I have 1/16 parallels here, 2 of them, 1/16 thick. And with that, and I measured this one, and it's 54 and a bit. And then from here to here, it's 41, let's say. So I subtract 10 millimeters because I need to be at 10 millimeters. This is 20 millimeter. I need to be at 10 millimeters. So that's 31. And this was 54 divided by 2. That's 27. So I have between 27 and 31. That's 4 millimeter of clearance here. So I can come with this, you know, be 4 millimeter, be able to drill this holes 90 degrees. So I'm gonna go with this plan. This is the setup. I centered the spindle with a rotary table. Then I mounted this. It doesn't need to be centered because I have 4 jaw. And then I centered the ring with the dial on this lip here. And then I put these 2 screws here and this parallel, one of them, and I swiped that surface, and it's aligned on that direction. And I'm not gonna drill the holes here. I'm gonna move this position here. So the hole should be here. These are 120 and I have 90 here, so I need to, this is 0 now in this position, so I'm not losing it, you know, that's my 0 here. So I'm gonna move this 120 minus 90, 30 degrees to drill this hole here, moving the spindle only on the x-axis, and then from here this hole rotate 120, 120, and then rotate again 15 degrees. Disassemble the table from the rotary table from the table, flip it 90 degrees and drill the holes from here, and then I'll rotate in 90 degrees increment. Okay, so I'm done with these holes. These are the original. They are more inwards than the one I did here. So now I need to shift 15 degrees and do the rotate everything and do the 90 degrees from here. I'm gonna set that up next. Well, I have some challenges here. This hole is too big for this nut, so I thought I'm gonna put this and it fits, but then the space here and even on the other side is too small to fit a 17 millimeter, and I don't have any way to tighten that nut, and there's another one on the other side. I have the same challenge. So, and there's nothing on this side to clamp, like this edge here I think is too small to clamp on that. I don't know, maybe if I put 2 clamps here, one here, this looks flimsy, and then nothing on this side. I mean, and also not enough room to do this either, right? Like there's no room there to put a bolt. in that position and based on that channel. So I'm not sure how to do this now. I have some push clamps, so they bolt on the surface, and then they have a tapered, movable, like a jaw, with a screw, and they push sideways. But there's not pressure from above. Although all my pressure is gonna be from above. So maybe I'll mount some 1, 2, 3 blocks, like block the movement to come this way. One here and one here, and then use the push clamps here. But even those I cannot use because I don't have access to the top screw to push. So I have to find something, because otherwise all this idea is not working. I have to think of something. I could use this angle plate, bolt it down. Unfortunately, I cannot here, only here in 2 places at least, so it's not pivoting. But this looks so flimsy, not enough surface to. And I was thinking, yeah, maybe use this one, but this one is even flimsier, like doesn't have enough power. So thinking maybe I have some C-clamps, like big C-clamps, long, like 8 inches between jaws. Maybe one jaw gets here, and then I put some 1 to 3 block stacks here and a steel bar, and I clamp between that. Let me try that, because I'm running out of options. I'm definitely running out of options. I am seriously considering this setup. So I have this C-clamp here, another C-clamp here. They clamp on the angle plate. The angle plate gets clamped on the table like this. No clamp on this side, but there's no way to go because the table has a flat surface. Angle plate here, and the pressure is from above. Now to align it here, I can put a dial indicator in the spindle and swipe this surface. So I'm aligned with the y-axis. And then I have to find my center here. Unfortunately, I don't have this surface machine, so I'll have to be creative and find the center by other means, and then do the holes. I think I'm pursuing this because I don't have other option. Kind of flimsy, but it is what it is. This is the setup to find the center. It's complicated. So I have a parallel clamped with this clamp on the 1 to 3 block, and they're sitting on 1 to 3 block, and the same on the other side. So the idea is making sure I'm touching that lip on the external diameter with this parallel. I'm gonna put the dial indicator in the spindle, swipe this surface here, making sure it's aligned with the axis of the machine, because this is aligned already. I swiped here with the indicator and I got 3/10 for a distance like this big. Do the same on the other side. So these are parallel and touching there. And then with the dial indicator in the spindle, swipe this surface, find the 0, right? And then 0 the DRO, the y-axis of that location. And then move on the other side, swipe this until I find the same 0 on the dial indicator. And the distance I will have on the DRO divided by 2, and I'll find my 0. So once I swipe this, I'm gonna clamp this so they're not moving on me. Pretty complicated, but I couldn't find another way. That one is clamped. I'm gonna crank on this. So I have maybe 2/3 over that distance. I think that's fine for my application here. I'm gonna move to the other one. Finish the other one. So let's load the dial indicator somewhere around 0 and crank on it. It's at the edge there. Pretty good. I'm happy with this. So now find the center. Finally, I have my zero now. I zeroed the arrow on Y, and I lock the Y-axis so it's not moving on me. Now I can remove this setup. I don't need it anymore, and start drilling 8.5 millimeter and tap with metric 10 by 1.5. We are at last hole. Okay, it's more like it. This ring it's almost done. What's left is to mount drill the holes in the back plate. Mounted it in position with this ring on that surface after the boring and stoning, and then take I have left here 0.1 millimeter. So with that I'm making sure that this was mounted on the spindle, this was machined on the spindle, so it's perfectly perpendicular. If I mount this here and machine, take that 0.1 millimeter I left, will be perfectly perpendicular on the machine axis spindle. So then when I'm mounting the chuck, it goes perfectly aligned. At least that's the plan. So next, need to check this up and find the location which go with these holes. I think it's like this. Yeah, hole here. There's nothing here. Oh, there is a hole here. No, that's not the position. Actually, doesn't matter because this hole is from the chuck. It's not the true hole. So true holes are this. Okay, this is true hole. Nothing here to interfere, so I can drill the hole. This is true hole. Nothing here to interfere. And the last one is this one. Nothing here. So then once I have this in position, I need to align this somehow, these holes, and put the high-speed steel plugs in place. I have to figure out a way to remove this, but I think I'm going to put it on the lathe and take a pass. This interior surface is not serving any purpose. So that's the plan. Okay, here is the plan. So where I have blue here, that's through holes, and I need to drill the holes here. So I want these holes to be equally distanced from the other ones. So if I put that in the middle like that, I will have no interference, and Also the that's not the position I want. Where is it? Is it like this? Yeah. So these are sitting between the other two, and I have about 15 degrees from here to here, right? So my screw coming perpendicular is not interfering with this one. Or I can do it exactly in the middle here. That's another option I can pursue, because you see there is a line here. That's the hole I have from already in the back plate. So that's also an option. These are not interfering with anything. So what I'm thinking to do is mount this in the vise face down on some parallels, and then use this and a dial indicator to align this position wise, right? And then use the dial indicator to center around this ring. That's where it's mounted on the spindle. So I'm very accurate here. I'm a couple microns accuracy. And then I'm gonna drill the holes in a coordinate system using X and Y, right? So that's at 90 degrees and then 90 degrees this way, and then the other. So once I'm done doing that, then I can mount this ring on the back plate. Right, so I can go mount this ring on the back plate and do that on the lathe. So with the ring mounted, this ring mounted on the back plate, I can put the screws here and adjust this by probing this lip here. So this lip is, it's centered on the lathe spindle axis. So then with these 4 screws and the 3 screws from the back, everything is clamped together. Then I can take it off lathe as an assembly and put it in a vise like this. Put this in the spindle. This is 8.5 millimeter, because that's the internal diameter for a metric 10 by 1.5. 8.5 millimeter, put it in the spindle, and just align by just that presence in the spindle, clamp it this way, and then drill the hole. I need 10 millimeters hole. So what I'm gonna do, I'm gonna center drill. I checked. This is long enough that it can reach the inner ring there, because it's long enough, and I still have space to clamp it in a chuck. And then drill 8 millimeters in this. This is 8.5. So then I can take the external ring out, use an 8 millimeter center punch like this in that hole, and do again alignment, and then drill 10 millimeter and mount the high speed steel plug. So sounds complicated, but it's okay. It will work, and I don't need this contraption anymore. I can do that in a coordinate system. And I just wanted to show you. See, these 4 holes were this 1, 2, 3, and 4 were done with that rotary table, and they came pretty accurate. I mean, I can push this, and it goes in the other hole. It's a little tight because it's exactly 8.5 millimeter, but see, it's pushed there. It's good that it's tight because I don't have a lot of play here. And then the other one, same with the other one. Pretty good. So yeah, that's what I'm gonna do. I'm gonna take all this off the machine, clean the table, and do that. One more time, this is how we run this. So I have this 12 millimeter carbide end mill. They fit pretty snug here because these holes were made with 12 millimeter carbide. So we're gonna align this with the axis, and this hole and the other hole needs to fall between these two in the middle. So that angle there is going to be 90 degrees. This angle is 90 degrees, right? 0, 90. Now this angle from here to here is 15, because from here to here we have 90, and from this hole to this hole we have 60. So 90 minus 60 is 30 divided by 2, that's 15. So then from 90, I subtract 15, that's 75. And then I add 60, that's 135. So I have here 135. And then I add 120 for this hole, that's 255. And another 120, that's 375, or 15 degrees. So that's this hole here. It's 15 degrees. And it makes sense because, this is along the x-axis, and they are at 15 degrees, right? So that's how I'm going to run this pretty much. And, take this out, drill the holes through. I'm not gonna put socket end cap on the screws. I don't want to put this coming from the back, and I'm gonna put this instead because they have a larger surface here and much easier to use a wrench than where is it? Then one of these, which needs more space there, that I'm willing to give, right? Because this is gonna be in the back of the back plate close to the spindle housing, and I think this is better. So I only need to drill the holes more than 8 millimeter. I need to leave some room there so we can move this ring around, right? So probably gonna do 8.5 or maybe 9 to allow this movement. We have pretty good alignment here. That's a tense indicator, so it's not that needle not moving. I already clamped the back plate, so that's good to go. Okay, so I did it with this. It's okay, it's not perfect, and again my spindle is not stiff enough to, and I don't know if this is round anymore. If I'm clamping here, maybe it deforms a little bit enough to show, but for what I'm trying to do here, this is good enough. I'm gonna go with this. I zeroed my DRO here, X and Y, so I'm gonna calculate what X and Y coordinates I need for 15, 135, 255, and drill those holes here. I had my angles wrong. Actually, these are the angles and the X and Y coordinate I need to run. So I'm gonna run, because the setup is flimsy, it's not sitting on the bottom on parallels. I'm gonna run 3 drills in each hole so I don't put too much pressure. Okay, so it's the one which is wrong. Should have been somewhere here. I'm gonna do that next. Go on the lathe, clamp this in the spindle, use the 4 screws here. Use these screws, 4 of them. So release this to push against this 4 until a dial indicator reads 0 on this lip here. And then clamp this on the back, come here at the middle and use a center punch and drill that hole. Okay, so I centered this. It's 1000. That's okay for what I'm doing now. And I tightened these screws, these 2 I have. So now I'm gonna take a skim pass of this surface to make sure that this plane is perpendicular on the lathe spindle. And then I can take this off, make the third hole. That's all she wrote. So I'm taking this off and making this hole here. And then I can put everything together. Well, actually, no, I have to drill these holes next. Well, this is my best option. Any other center punch, it either doesn't fit or it's loose. And it's okay because the hole is 9mm, right? Going over a 8mm thread. So I'm gonna go with this for the lack of other option. So now I need to reclamp this, assemble everything together, center again on the lathe, and then come and make these holes. This is my setup to drill this hole. So I put again the 12mm carbide in the holes and I align this. It's not perfect. I think I have 1/1000 of an inch over, I don't know, 1 inch, 2 inches, something like that. But it's okay because the set screws which are get mounted here are gonna be rounded at the end, which is pushing against the carbide, so it's okay. So then I'm gonna put this in the chuck, align it here, center drill, and then drill 8mm. This is 8.5. or do all of them like that, and then mount it back and use an 8mm center punch, do the alignment again, and do the 10mm holes for the high-speed steel, which I need to cut. I'm thinking like 12mm plugs. Cut them in an angle grinder and then machine them with a carbide to be flat. I don't think I can cut this on the lathe, like cutting them off, because they're hard. That's 8mm. I'm going to the bottom and zero my DRO. So I can go, I should go 12mm, but because there's an angle here, I'm gonna go 14. So now an 8mm center punch should fit in here, in that hole. Yeah, it's kind of loose. I think I did 8mm. Yeah, that's 8mm drill. What's this then? 787, 790. That's supposed to be 8mm, but a bit loose. I'll see how it goes. I'll do the rest off camera. I removed the ring and I'm ready to drill to 10mm. There are 8 now. Centered here, I'm gonna use 9.5 drill and 10mm reamer for this. Okay, so it fits. I think I need to do a scratch here, like with an angle grinder, so air comes out. And I'm gonna use Loctite for this. Gonna use this Loctite 648. To mount this. I'm gonna do the other one off camera. All 4 holes are done. 1, 2, 3, 4. Fits pretty snug. It's not gonna be a press fit because I rimmed them. I didn't want it to use a boring bar and struggle. It doesn't matter. I'm gonna be seated to the bottom and with Loctite. It's good enough because the pressure is this way. Now I need to figure out a way to cut this high-speed steel and then put it on the lathe, make the face straight. If that doesn't work, I'm gonna put it on a surface grinder and Loctite them in, and this project is done. I'm gonna assemble everything and see how well can we adjust the 5C chuck, 5C collet chuck. I managed to make these high-speed steel inserts on the lathe with a carbide. I clean them with acetone, and I'm ready to glue them with Loctite 648. I can still pull them out with a magnet to do that. And see, they have this scoring line, so the air is not trapped there. And then once I set them all in with Loctite, I'm gonna use the ring with the actual set screws which are pushing against, and I machine the heads, reduce the diameter and make them flat so they push against that surface. So I'm gonna Loctite them in off camera. I have to wait 24 hours, and then we'll put everything together and test it. 24 hours has passed. I have mounted this on the spindle. I'm gonna mount the 5C collet jack and see what kind of accuracy can we get and how well can we adjust for runout. It's not sitting properly. I change the orientation. Maybe these holes are not equally spaced. Or am I threading into the wrong hole? Yeah, I'm threading in the other holes on the back plate. And there is a screw there. Okay, so let's lock this tight. I have a 3/4 inch dowel pin, 3/4 inch 5C collet. Let's try with this. Check keys. Okay, I think it gripped like that. Let's see where we are with the 1,000 dial indicator and see how well can we adjust this. Let's do it here first. So let's do this a 0 here, and we are what, 5, 10, 15, 20, 22. So we need to split that in half. Now should be between -10 plus 10. Okay, so I need more than this. want to snag a little bit these bolts from the back. Okay. Yeah, okay, so to move in here, release from the other side. No, the other way around. Okay, so we have 0 here. Let's see this one here. This needs to be pushed this way. More. More. Okay. Close to 0 now. Question is, how does it look here? It doesn't look good. Could be many things. Could be the taper is wrong on the seating. Could be the collet. Could be these planes are not parallel, so it will wobble like this. I guess we can find out if we put, or maybe the dowel pin is not straight. Let me try with a precision shaft. Let's see how that looks like. Clean it. I don't know how straight this is. I will see. See if it's repeatable. We get the same runout here. No? You're not. It's 3,000 off. Not even repeatable. I can see it wobbling here quite a lot. So not sure. Yeah. Not sure how well it's sitting. See? You have a lot of flex here. So I'm pushing and it stays there. So I'm not sure how well this grips to keep it in position. Let me try with ER collet. again can have the same problem. Too many interfaces, 1, 2, 3, 4, 5. ER20, I know it's not ideal. Maybe I have a 19. But 19 will be smaller than 19.5. I'm gonna go with this. Let's see where that puts me. Of course, we need to center it again. Because we are how much off? 5 thousandths. 5 thousandths off. So let's do the adjustment again. See, that's why I want this adjustable, because I cannot get enough precision with the collets or the taper of whatever, but this allows me to dial in whatever I need to dial in. Okay, so I'm 1,000. Now we look here. See, yeah, Collet looks better. Right, so we go here. And I can put a 1 micron dial indicator and just go down to a couple microns. So that looks like so. And then we go here. See, the needle stays there, right? And yeah, it's a little bit more there, but over this distance. So I don't know, I feel like ER collets are better than 5C collets because they have a longer grip. Question is it repeatable now? Let me take it out and put it back and see how it goes. So lock the spindle and take this off. Oh, I need to lock this guy because it's getting unscrewed from the spindle. Okay, so just move it around, right? It's like whatever, something like that. Let's see again where that puts me. Yeah, it's similar with before, well, maybe a little more. I'm getting a thousandth of an inch, right? Thousandth of an inch or so. Not that bad, not that great. I was expecting half a thousand. Let's see if we go here. Yeah, it's a little bit more. 2000s. Actually, I can work with this. If I really need very precise, I can always mount this directly in the spindle with a drawbar, and I don't have so many places where you lose concentricity and so on, right? So it's 1, 2, 3, 4 on that taper, 5 on this taper, and they have the collet, that 6. And here you have 1 on the spindle, 2, 3, right? So it's less. I can work with this, and if I need something really accurate, use that directly in the spindle tapper. I think I have another adapter, a smaller one. Let me check that. Again. This smaller one, which I was using on the indexer, because that's a 5C as well. So if I need something smaller, I can use this. Well, you know what? I never measured. Let's do this. Let's align for runout on the taper here at one distance, right? And then if you move in, it should still be aligned. It means the conical surface here is centered around the spindle axis, right? Because if you measure at one position and you center it, it should be centered at any position along the length of the taper. So let's try that. Let's try that. Thinking to put the dial indicator here. Yeah. see how we are at this position. Okay, now 0. It moves quite a lot. So let's align this here at this position first. So maximum on one side. Okay, that's that. Make that 0. Okay, and the other side it's 3,500. So I need to go half that distance to be in the middle. Okay, so now let's do the alignment here with this, and 3/10 here on this direction, plus minus 3/10. Let's do the other one first, because that's 1,500. So go this way. Minus 3 plus 3. Okay. So now we have 1,000. Okay, let's do better. Okay, so we are a couple tenths there, right? Couple tenths. Now let's move at a different diameter. No, the different length there. So I'm gonna back this up, move in here, and then go to 0 again. Okay, let's see what we get now. Yeah, okay. Looks like that taper is good. I mean, maybe one extra tenth. Let's go more deeper to the end there. Okay, at the end, 0 this again. Oops, I overshoot. Okay. Yeah, 4/10. You know, this might not be dead accurate. I might have 2, 3, 4/10 on that taper length, and you know, that's gonna get amplified with the distance. Plus, you have the 5C collet, which has its own errors, like taper concentricity with the hole. So that's why I wanted this, because you'll never get down to 1,000 or less. Like, I can dial down to couple microns here, like, you know, 1, 2 tenths, and machine. Yes, I think I'm okay with this for what I do here. You know, my spindle is not that stiff. If I pull on this, you know, it moves. So imagine when you machine, put cutting forces, this precision will go away, right? Because it's not stiff enough. But I'm satisfied. I mean, it gives me the options to use all my 5C collets, which I have been for like a couple of years, and jump easily from 5C to ER. And if I really need really accurate, I can go with this. This is accurate to the taper here. I don't see the needle moving. I don't know, I was lucky with this one. So all depends on how good the collets are, right? So I'm satisfied with this, and yeah, that's it.